Got a new wall, I think.
Yeah, he didn't show up.
Oh, okay.
Welcome to the ARW discussion, folks. I see we've already got a group of people watching or commenting. Here's another arrival, which I bet's Chuck, or maybe not. No, that's Aaron. Okay. So anyway, the subject for today is DROs, buying them, installing them, using them, repairing them, building them. We're going to get as in depth as we possibly can. We have Phil Hodges down there. He built his own DRO, and we have Robin Renzetti, who is sort of like a senior member of the Internet Machine Shop group. And so I know we've got people here that know what the heck we're doing and what we're talking about. And everybody wants a DRO, or else they've got one and they want maybe another one. Okay, now Aaron is forgetting the name of his channel.
Always Sunny in the Shop.
Yeah, that's it. I'm old, so I forget things. You're over in Arizona, aren't you?
I am, yeah. I live in Phoenix.
There you go. There's nobody hardly else in Texas but me and Joe Pye. So it's kind of lonely around here. Well, I take it back. There's Tinker John. But I was going to have a group one time of all Texas YouTuber creators. And I couldn't find but the three of us, so I had to give that up. Oh, he's got a Cincinnati mill. I think it just arrived or something. Anyway, would anybody like to tell us about the what kind of scales do you like on your DRO? You like magnetic or glass? How about you, Robin? Which one do you recommend?
Well, I like glass scales mainly because on the Heidenhain readouts that I use, the electronic subdivision happens in the control. So you can take a like on my Harding, once you get rid of the compound, having a digital that reads out to 50 millionths on diameter, which means 25 millionths actual movement increments, is a really handy thing. It actually works. It's not a useless joke. And you can even go below that. You have to be careful to not think that it's necessarily accurate at those levels, because the electronic subdivision is only as good as the purity of the sine waves coming out of the encoder. But the Heidenhains are really good. Trust me, they're amazing. I actually have old Accurite mini scales on there that are direct. And I'm probably not telling you guys anything you don't know, but scales come in two types: ones that have the actual interpolation of the sine wave done in the head, and it sends out a square wave in quadrature that the digital then reads, but then you're locked into whatever resolution that scale is. The opposite of that's a sine wave input with a digital that can interpolate various readings. You tell it what you want to break that scale increment into. So that's really handy. It's expensive, but for higher precision stuff, it's worth it. But glass scales, you need to mount them really well, protect them really well. I've done videos on how I put them on my Harding and in my Bridgeport. You do it well, they last forever. Mine are in my Bridgeport are actually internal. It's inside the knee and inside the table. You can't even see them. They've been in there for 20 years. And the fact that nothing gets to them means that the glass scale, the negatives of a glass scale go out the window. So that's my 2 cents on that. But the others, I don't have anything against the other scales, but yeah, that's it.
Is that what you
Okay.
used on your grinder, on the surface grinder, when you did that?
The surface grinder actually is the mechanical resolution of the surface grinder, meaning the belt reduction, the screws, and whatever, with basically very minor micro stepping. I'm only micro stepping at 5,000 counts per revolution, which is actually pretty coarse. My vertical travel per increment is 5 micro inches. The cross travel is 10 micro inches, and the table travels a tenth. So what I did there with that PLC is I'm using the absolute motor positions, which basically once you home it, there's a counter going on for the motor position that doesn't change, other than losing position. And by taking that and doing the math on it and making a display routine, I'm actually just sending the motor position with the math to turn it into whatever divisions I want onto that PLC. So it's actually not a digital readout. It is but it's actually measuring motor position, not actual position.
So you're just taking the data off your stepper motors then.
Yep. Now
Open loop, not closed loop.
yeah, open loop, and now it's extremely consistent, but it still has backlash.
Right.
But the one magical thing that I can't stress enough, but that I kind of found on this for downfeed wise, this is just an ordinary Harrod grinder. It's been scraped very well, and the belt drive system is very tight, meaning there's no backlash. But it's stupid simple, and that is, if you have a PLC, you just make a routine that when you want to downfeed an amount, you actually move up, let's say a settable amount. In my case, I move it up 50 thousandths and then come down the 50 thousandths plus whatever increment I set.
Mm-hmm.
And so doing 10 millionths moves is not fairy tale. And the weird part is, because you're getting rid of the stiction, you're getting rid of the stick slip, you're getting into the dynamic friction mode by going up and then coming down in a consistent manner. And so you can I literally can feed 5 millionth increments. I did some, if you follow me on Instagram, you've probably seen some of the things I did there.
Oh yeah.
So that works incredibly well. And the weird part is you can move up the same amount and it's just as accurate. So how many machines can you move down and tell it to move down 5 millionths and then tell it to move up 5 millionths and have it actually do that?
Mm-hmm.
Well, it does it because it's moving up, getting out of the static mode and coming back down. And it works incredibly well.
I don't
So it's
actually
not-
have anything that can measure 5 millionths.
That's on the coarser scale on my indicator.
Yeah, that's only a half a tenth, Harold. What are
There
you
you
talking
go.
about?
No, that's a 50th of a tenth.
What kind of a PLC did you use?
It's a Automation Direct BRX PLC with a HSIO module, and that BRX PLC has lots of motion commands in it. It has trapezoid, it has S curve with jerk movements, very, very powerful. So I mean, there's a lot of legwork on the PLC programming to do all the digitals and the presets, because you can do all that stuff with just plain math with the PLC. You're using the motor register as the absolute machine position register, and then you just do math on it for presets or for zeroing or whatever. And I'm just sending it. It's I'm not even using Ethernet to the HMI panels. I'm just using RS-232 at, I don't know, 19
92 baud.
yeah, baud, and it behaves amazingly well. It looks like a really good digital, and it works good.
What
How about?
I'm sorry.
How
What
about?
I was wondering what software you use for that Automation Direct.
It's the free software for all their PLCs. All their PLCs, the software,
Free. Oh,
download
wow.
it free. Download it if you don't even own it and play with it. And I'm one of these guys that just dives in. I'm not a PLC programmer. I mean, I've done lots of different programming and stuff, but that is the sweetest programming language I've ever seen in my life. Everything you think would be handy for PLC programming, it's just like magic.
Well,
It's not ladder logic then.
I did
It
Siemens.
is.
I did Siemens on my auto step, and they want to sell you the PLC, but then they want to turn around and sell you the software for another $2,300.
Yeah.
Yeah, and the that BRX PLC I think was only like 3 something, and the HSIO modules maybe I think $200. And yeah, their stuff's amazing good. I've built 3 machines that are in industrial use, doing like what my surface grinder's doing, but a little more sophisticated on automatic routines and things. And they've been flawless. They just run. They just run and run and run. You'd think it was like cheesy stuff, but the that whole BRX line is actually designed and made in the United States.
That's good. At least somebody's got a job.
Yeah.
Let's ask Phil to tell us about his DRO. He built a DRO also, and I'd like to hear about that.
Hi. I disappeared there for a short while. My laptop was playing up, but yeah. So I started out by caveat first off, total amateur. I'm not by any means a professional here, so I know, having seen loads of your guys, you know, the output you guys do, it's brilliant stuff. So I'm kind of just tagging along here, but I can tell you what I did. So I started out with the really cheap, you know, eBay glass scales and the Chinese DRO box, you know, you mount. Started out with those, and you know, I've got one on the lathe, on the mill. I'm planning to put one on a grinder. I've got a 540, so it's only a little surface grinder, but I'm planning to put one on there. And the one I want to put on the grinder is sort of a homebrew one. Now, obviously, I only need to measure the Z-axis, the Z-axis. And I had a spare scale. So if anyone's had a chance to watch one of my videos a while back, I sort of went into analyzing the signals that came out of the glass scales. And these are they have the A and the B channel. It's just a standard linear encoder. And I'd never really played with one before, so I thought, you know, part of my job in the real world is to take things apart and to find problems with it, and to, from my perspective, look at it from a security perspective. However, it's electronics at the end of the day, so I sort of took it apart, and I've actually still got the remains. So where's it gone? So that was the remains of one of the sensor heads that I took apart. And that was just to find out what the actual circuit was doing. So once I was happy with that, and I knew that it was, that it basically uses, there's 4 channels inside. I think, Robin, you may have sort of gone into quite a bit of detail there before. So basically on these cheap units, there are 4 channels, and it fundamentally, you've got 4 LEDs and then 4 photoreceptors on the other side. And they're offset by, I don't know, a few millimeters. And as the glass scale passes through them, the etched pattern causes the light that's detected on each one of the channels to vary in amplitude, for want of a better word. It's the voltage changes. And inside the actual head, there's 2 comparators, and it takes 2 adjacent channels, and it looks at the sign as the glass scale slides across. As the light is attenuated, the signal will go down, and then as it moves past the sensor, it will then climb back up. And because all of the sensors are offset slightly, some are climbing while others are descending, and the comparator looks at 2 signals, and as one is rising, once it passes the level of the one that's coming down, the logic flips. So it goes from one to the other. And it means that even though you've got analog coming in, you can quite accurately determine when it transitions from true to false. And you've got 4 inputs on that. So you've got the A channel and the B channel. And you can use the A channel and the B channel to calculate distance moved and direction. So that's what I was doing with this unit, and I basically used that combined with I started out using an Arduino, but I'll be I'm not sure if I'm still connected.
You're connected.
You're good.
You're still there.
He may not know we're here. You're still connected.
Yep.
Yep. He's gone.
Well, I guess not. Well, that was interesting. That he really dives into them just like Robin does.
Yeah.
Those
Well, he's
things.
hooked it up to an Arduino, and
Yeah.
used the Arduino to drive his display.
Well, he mentioned 4 inputs. I think that's probably differential inputs. He's got an A and an A naught and a B and a B naught. So
Yep.
technically, it's still only 2 inputs.
Yeah.
I think mine has 3. I think it has an index as well. There is an index mark on the scale, and it talks about finding the reference mark somewhere. So a lot of those will have quadrature encoder with index as well.
Yeah, DROs are like a toaster to me. I plug them in, they better work.
Well, yeah, yep. Are you back,
Okay.
Phil?
I am sorry about that. I think my network at home is running a bit slow, so I don't know how far. I don't know how far I got. I started rambling, I'm afraid. So
Well,
I
we
don't know
heard you
quite how
talking
far.
about the inputs and talking about hooking it up to the Arduino.
Brilliant. So yeah, so this thing gives you 2 outputs, channel A, channel B, and using channel A and channel B, you can. It's a standard encoder logic. So you've got four potential phases that you can be in, and by looking at the state of the 2 channels, the A and B channels, you can calculate if you're going this way or if you're going that way. And also, each pulse is a step in the resolution of the scale. So, for example, the cheap scales that I've got, they're 5 microns in resolution. So each one of those transitions from A to B, or the logic flip from on to off, that's every time it transitions 1 or 5 microns along. You're limited basically by on the optical ones by the resolution that you can actually engrave onto the glass scale. So I believe that you can get 1 micron scales. I wouldn't like to go any smaller than that optically, unless you would start needing to have lenses, and instead of just using a cheap LED, you'd have to focus the beam, because the light would be so spread out that it would leak the output from one and would leak across to the input of other devices. So I don't know what the exact limit is. I'm sure there will be some documentation somewhere that gives you the maximum resolution that you could have optically. But I'm willing to bet that it's smaller than a micron, but I wouldn't like to go any further than that. I know that some of the other sensors can go a lot smaller than that, but as I say, I wouldn't like to push the optical one. So once I had those 2 signals, I started tinkering around using an Arduino just to count the pulses and to work out whether or not I was going up or down, as it were. And just simply, you just have a register. Every time you detect a change in state, in phase, you work out which phase it is. Are you going to the left or to the right, or up or down, whichever? And you just increment or decrease the counter by 5 microns, and then something just to display it on the screen. So from my perspective, that's all I needed. However, once you have that value, you can then perform any kind of calculations on it. So I know that, if you want to control the position of something, you need to know its absolute position. So once you've sort of powered that machine on, reset it, that's your position. And the repeatability on these scales, even with a cheap Arduino, is pretty spot on. I ran a few tests, and you can sort of zip it back fairly fast. And when you hit that 0 point, it's back on 0. Because I was worried at first that the speed at which these logic states change would be faster than the Arduino could keep up. And it doesn't appear to. I mean, I think, was it you, Robin, was saying before that you were using RS-232 for signaling, and even at 19.2 board, you're not sending that much data. So as long as you're not sending long strings of information and you're just sending numerical values, then it's absolutely fine. So that's basically where I currently am. So I've got a couple of little projects on the go. One of them is to tap into the on my lathe. It's an old Colchester, a little student, and I fitted the DRO to that when I first got it, and the scale as you're winding in, as you're making a cut across the face. What I want to do is to control the VFD. So I want to tap the signal coming out of the linear scale. So I can set a sort of start and a finish point. So you'll basically wind into point A, click, whatever speed you want it to be, then wind out to your maximum size and say, right, at this speed, I want it to be, 1200 RPM or whatever. And then as you then start winding in, it takes into account the position and gradually slows down or speeds up depending on which way you're going. And that can be done just by directly driving the VFD by introducing. I think you can either talk to, depending on the VFD, you can either do it using a serial port or you can actually do it by varying an analog input. So I'm yet to decide which one, but that's basically what I'm looking at.
So you're trying to do constant surface feet.
Precisely. Yeah.
Yeah.
Absolutely.
Pretty standard on CNC stuff.
Yes, absolutely. You see it and you hear the motor as it's working out. You hear the motor start ramping up, don't you? So, and it's I hate that surface finish. As you're working in and you go on a large piece and you go from a really nice finish and then it suddenly starts to go all. You get that really weird pattern, and I hate that. I'd like to see the surface finish the same all the way. So
you didn't encounter any index output on your DRO head there or your scale head?
No. So the cheap ones, they only have the 4 channels. They don't have. You can get some, which I think I overheard you talking about just as I came back online. There are some that have on the glass scale, instead of just the vertical bands, there are some that have other indexing points, and that's so as you're working along, it kind of goes, right, okay, I know exactly where you are now. So it's usually 2 or 3 bands that are etched along with the normal band.
Right.
And that gives you sort of like 3-bit encoding, and that gives you a position, sort of an absolute position. So it knows when it passes that point that you're at 6 inches or whatever it is. Yeah.
Yeah, mine are cheap, but they do have an index, just a single index mark though.
Yeah.
There's something that I'd like to bring up too. When people are installing their own scales on their machinery, as an add-on thing, I've noticed a lot of people put the X scale behind the mill table, so to speak.
I did that.
And when you've got a smaller mill, you've just lost 2.5 inches of Y travel right there. Plus, putting that scale in danger of being crushed.
Well,
so I prefer to put them on the outside.
I can answer 2 of those questions. Number 1, you put a bolt on the back to keep it from crushing the scale, so you'll run that bolt into the column.
Good
Number
thinking.
2, I didn't want to sacrifice the front T slot because I can bolt something to that front T slot on my bridge port and swing the head over and let that part hang all the way down to almost touching the floor. So that's why I put mine on the back side.
Okay. But everybody's got a preference. So the first one I ever installed was on a little Grizzly, one of those wrong food type. And I didn't have enough travel on the Y-axis that I felt like giving up any of it.
Take the
That's
table
what
off.
mine is, Harold. I have that situation, but I have the cheap eye gauging scales, and they're so narrow that I only lose about a 1/2 inch on the Y travel. And it was worth, like Billy said, not giving up the front of the table where my stops and all are. So
The other possibility is like Steve's saying is use the magnetic scale for that particular one, the low profile ones. You can get away with 1/2 inch. Or, like Robin was saying, take the table off and figure out how to mount it up on the inside, or extend the axis. I mean, there's a number of different ways.
There's more than one reason for that scale, or more than one plus of having a scale in the center of the table, and that's minimizing Abbey errors. Basically, where I don't know if you guys are familiar with it, but basically it's the error that's caused by your scale being, you think of it as the analogy that's often used is spokes on a wheel. So if your scale's halfway up the spokes on the wheel and your actual table position where you're working is out on the outside, there are two different circumferences there that aren't matching, meaning that what you measure, the scale actually measures in distance, is different than what's happening at your work.
Mhm.
So anytime that the scale can be centered on the actual working zone, it minimizes those Abbey errors. So like on my lathe mounting, having the scale in what would be considered the dangerous, not the place to put it location, on the left side of the cross slide directly under the tool bit, that eliminates the Abbey errors in that axis because the measuring scale axis is directly vertical underneath the tool bit, unless you got a long boring bar or something, but it optimizes that situation. And my theory on all these things is put it where it belongs, do what it takes to guard it and have it happy in that place. It's worth the effort. I've spent 2 or 3 days putting digitals on, and that might seem like exorbitant, but my machines have been running for over 20 years without a hitch. So that time spent in overdoing it on protection, making sure that the way you mount them is really, primo and bulletproof is well worth it.
I have some issues with my Z. The scale's on the right hand side, and of course my gib locks. The table or the knee locks are on the left hand side. And when I tighten that lock up, it cants the knee just a little bit, and you can see the error. And you take the lock off and you relock it, and it's still the same setting. So it's doing something.
That's a whole other topic.
That is a whole other topic.
Meaning, if you intend to do any precision work on your mill, if you're drilling holes, don't use your locks unless they are reed locks that are non-influencing, because all you have to do is put a high resolution indicator on your table in the direction that the gib is going to push, and you can say to yourself, wow, worrying about a few tenths here or there is totally irrelevant because however hard I tighten this gib changes my location.
Right.
So if you're going to do something precise, don't touch anything. Have your gibs adjusted well, do your moves. Another item that people don't think about is most all of the level of scales that we're using have the reed head actually ride the glass scale. And it's basically spring loaded. Sometimes there's rollers, slides, whatever, but basically it rides the scale so that its alignment to the scale is totally uninfluenced by minor machine errors. But you have to remember, it's driven by sometimes just a little wire, sometimes it's just got a little ball socket. And if you want to do precise work with a digital, you have to forget thinking, in most of the work, your everyday work, forget it. But if you actually want to understand what's going on, you need to realize that you're going to get two different readings approaching it from two different directions. You might not have an indicator that can see that, but it is. Just the elastic difference in pushing on that push rod or pulling on it is measurable.
Aaron, do you have DROs on all your equipment?
You're muted.
Oh, there we
Yeah.
go. I couldn't find the button. I'm using my phone to record on, so it was in a spot that I wasn't expecting. But yeah, so I've got a DRO on my Bridgeport. It's a Newell Topaz. So that came on there when I bought it from an aerospace shop here in town. And then I installed an Accurite, what is it, a 200S, I think is the model name of my Accurite. So this is a one I installed last year from after they were acquired by Heidenhain, if I'm saying that correctly. I apologize to a German listener if I did it wrong. But yeah, I kind of took a 70% of Robin Renzetti approach, as opposed to just slapping it on there and making it happen. And went, pretty deep into the machine to try and get it as rigid as possible. I used ground stock to hardened and ground stock to mount onto the cross slide, and then mounted the scale onto that. And it's worked out pretty well. My cross slide scale reads down to 1 micron, and then my longitudinal, Z-axis measures to 5 microns. And so far, I've had, really good results with it. Interestingly, that came up. My Bridgeport also has the, XY or the X scale on the front of the table, and it's always irritated me because of that loss of that T slot, and just it gets covered in chips. Even though it's got the guard on there, it's just kind of always in the way. So,
Okay. There was a question about cutting the scales, and I've done it a couple of times. Glass scales, I don't have any magnetic. But what I did is, take the rubber seals out of it and the reed head and everything, and turn it upside down and get some of that real dense styrofoam, and pack on each side of the glass scale right there where you're going to cut it. And then I just stuck it in my bandsaw, and it just cuts down. There's hardly ever any chipping, at the cut, because I guess that styrofoam's holding it so good and steady, because I really cram it in there tight. So I wanted to put that in case somebody's wanting to cut a scale down to be more equal to where they're using it.
Well, if you did that successfully, I think you should take a trip to Vegas.
Oh, I've done it more than once. The first time around, I didn't get as good results. I had cracking back about an inch and a half, but the second time, it's almost just a total straight, clean cut. Just a tiny little chip off the edge.
What kind of a blade did you use on that? Do you remember?
It's one of those two different pitches. I think at 12, 14, something like that.
Variable, yeah.
Very
Yeah.
pitch.
We don't need to talk about my bandsaw because I hate it.
I think I saw, it was a long time ago, but I saw Robin cut a glass scale with I think it was like a diamond coping saw or something. You cut your scale?
Yeah, these were, I found a really nice Heidenhain real high resolution scale, one that can read down to like 2 micro inches. And it was longer than I needed, but I looked around and thought, well, maybe there's a spare head on here, and like 1 in a billion chance, a actual spare new reed head. So I thought, there I go. I'll cut the scale, put the other reed head on, and I'm good to go. So I took a much a safer approach, where I took a 3/32 end mill. I milled through the case on the top and down one side, and then took basically what was a diamond bandsaw blade, just a segment of it, and literally just sawed through with the diamond, a fine diamond, and just very gently went through. Same thing. I had the things packed on either side to protect it from there, but sawed right through, and then very carefully deburred with a fine diamond file, deburred the edges of the scale so that the reed head didn't get scraped, because there's typically chrome on glass is what's done on those for the actual markings, and they're very delicate. So deburring those edges, if you're going to slide a reed head on, is really important. But yeah, I did that, and that was really uneventful. But yeah, a much more reserved approach to cutting a scale. And yes, they do work.
I think I was holding my breath through that whole video watching you do that.
I think I watched Del Derry do it with a miter saw or a chop saw.
Yeah, he did it.
Yeah, it looked like it worked. Yeah.
It was like, holy crap.
It seems like if you've got that glass scale packed in tight enough that it doesn't vibrate, that it really helps a whole lot. I just turned the U-shaped part of the scale up and set it in there, and I cut that thing. Because they don't come in exactly the lengths that I want them,
If it was me and I was going to do a quick and dirty version, I would get one of the Lennox diamond blades that are meant for sheet metal. I forget what the name of them is, but they are diamond. And I would just use that with lube to go through the aluminum and the diamond. The diamond's going to cut the glass, but just be real gentle and give that diamond blade a chance to cut. And I think you'd have just about zero chance of breaking it. The glass is mounted in the scale body with silicone, so there's a little bit of damping of the blade in there. So as long as you don't impact it and go berserk, an abrasive method is going to work okay.
Yeah, I didn't have anything abrasive handy at the time, so I went with the saw blade. I can see where it would be a lot better. That's for
Hi, Randy.
Hey, how you guys? I
Hello, Randy.
sorry I was a bit late.
Better late than never.
Oh yeah.
Missing the party there, Randy.
I'm glad, Robin. Nice to see you there. I'm glad you showed up.
Aaron, I really like that lathe you got back there. Every time you start your channel, you reach over that beautiful, shiny, clean lathe, turn it on, and I always think, dang it, I wish that was mine.
That's his eye candy back there.
Sometimes that's kind of my thing. Is I'll just sit out here in the shop and just kind of look at it.
Well, I can see where you would.
You bust out the wax machine.
I don't know what that color.
Absolutely.
I don't know what that color is technically, but I think it should be green with envy.
Exactly.
I mean, you guys have all got a lot better machinery than I've got. I've got a Craftsman 12-inch metal lathe. So I mean, almost anything is more advanced.
Well, you've
Harold,
got
of
an
all the
ability to
people
move here
on
pretty
the-
easily.
Of all the people on the board today, I probably represent more the hobby machinists, a little bit more crude. You and I are a little bit more in the same ballpark, but
Yeah.
as far as the DROs that I use, I thought I was saving money by going with the eye gauging setup, and this is actually the Z scale that I never put on mine. And then I bought the blue DRO setup. I had a Android tablet that I planned on using for the display. And after I got everything all set up and went to download the app onto the Android, it was too old and it wouldn't take the app. So then I'm at a point that I bought the eye scales, I bought the blue DRO, and now I got to go out and buy a new tablet. At that point, I'm not saving anything. I should have probably just gotten a complete DRO system, spent an extra $100, and because there are some reasonably priced systems out there that are pretty good.
Oh yeah, if
But
you
all
look
that
on
means-
eBay, there's lots of low price systems that they work accurate enough for me. They may not be good enough for somebody really a pro and doing precision work.
Yeah.
But
Well, the
for
eye
me,
gauge
they're-
scales work fine for what I do. I have them set up on the mill, and the resolution on them is a 1/2,000. It's 5/10. And for positioning holes and so on, drilling and everything that I do in my shop, they're more than sufficient.
yeah, isn't that a beautiful lathe? Man.
Aaron, what do you spend 20 hours a week polishing that thing?
No, don't be ridiculous. It doesn't take more than an hour a night.
Oh,
Okay.
there you
That's
go.
a turtle wax.
That lathe needs
No, I
more
don't- I
rat
don't
and
use
less
turtle wax.
rod.
It's a Carnauba Brazilian wax. You can eat it if you want to. It's so pure.
Well, you have dinner out there on it every night, right?
Oh yeah, absolutely. That's why it's
Yeah,
that's why I
because
like
his
having
wife
it
kicked
so
him out of
big.
the house.
Yeah.
So my DRO, I'm going to talk about the cheaper stuff because, being in the maker space, I didn't want to throw too much money at this thing because it's going to get abused. I spent $650 for this complete setup behind me. 4-axis. All the scales came measured out correctly. I didn't have to cut anything, and it seems to be a good unit. It's I think the scales are 5 micron. And for consistency's sake, I bought a 3-axis from the same company and stuck it on the lathe that we refurbed. I don't know. I've had it for about 3 years now, the 4-axis, and I've not had any issues out of it. But I'm not using it in a production environment, so it's not getting a ton of use like some of you guys would be. So I don't know how good it is or how long it's going to be around.
Well, I can say this much: I'm a hack machinist. You know, if I can get within a couple of thousand, that's doing pretty good. You know, and when I got the DRO, put it on the mill, it improved my work just 100 times. My accuracy was improved. The things I would willing to attempt to do were, you know, further advanced. And if you don't have one, save your pennies and get one. Is all I can say.
Oh yeah, I gotta agree. You know, they're worth every single penny. Even if you buy it and a less expensive type, you know, I have a DRO Pro one on my mill, and the speed and the accuracy just go up tremendously as soon as you have one. It's amazing.
When I first discovered CNC, I found out that they didn't read the DRO to find out where they were, and that really puzzled me. You know, I thought, well, why would you pass up such a way to get rid of, you know, backlash like a DRO? I mean, you know where you're at.
Well, I mean, you got 2 types of CNC. There are some that's closed loop that do read the glass scales. That's your higher end ones. In fact, you got some that will actually be double closed loop. They'll read the encoder off of the servos or the steppers, and they'll read the glass scales.
Well, I would think so. It's just that sort of blew my mind right off, and I thought, you know, obviously I don't know anything about it, but it just seemed like they were throwing away all this free accuracy, you know.
I got a question for Aaron. That Heidelman setup you've got, is that the one that uses the ball inside the tube?
No, it's glass scales.
Oh, okay. What?
Yeah, the Newell on my mill.
Which one am I thinking of that uses a hollow tube with a ball in it?
That's what I got on my mill actually. Oh, get over here and show. Well, I don't know if you can see it under here or not, but there's a.
Is that the Newell?
Oh,
okay. No, I can't.
Yeah, this is it's not very good, but it's called a Spirocin.
Yeah.
As in like sphere, and then O synthetic SYN.
Right. Now what's the advantage of that? I mean, is it impervious to coolants and oils and stuff, or what's
I think that's the idea,
on...
yeah. Because it can't, you know, because it's a sealed system, there's really, you know, there's not a way for junk to get in there, and you can I think they can be mounted more off center or out of alignment than even a magnetic scale.
So they're more forgiving on the installation.
Yeah, yeah, exactly.
And what resolution does that scale come in, or how far down does it go?
I think those on my machine are 10 and 5 microns.
Oh, okay.
So they're a little bit larger, you know, larger increment than my lathe, but I didn't get to choose that one, so I'm not going to complain.
No, I knew that you had one that took the steel ball in the tube, and
yeah,
that was
it's worked fine. So that machine was new. It's a Sharp knee mill, and it was new in '97 and used in the same spot for 21 years, I guess, when I bought it. And that was as far as I can tell, the original DRO that's working great.
Hey Aaron, what's the longest scale you have on your lathe there? How long is it along the bed?
The bed is, so it's kind of over length, but because of the size of the tailstock, but the bed is 54 inches between centers. So the scale that's on the back of the bed for the Z travel is, I think, 60 inches.
Yeah.
And that gives you, the over travel you need so that the reed head, can go beyond where it's actually needed and still have a spot to read on. So that was just based on their recommendation.
Yeah, I'm thinking of putting the one on my big lathe, and I need to have something at least that long.
Yeah, it's Accurite is pretty good in that regard. There's a lot of different choices. You can get 3 and 2 axis mill and lathe packages, and they'll have you basically customize which length of your scales you need, because again, they say don't try to cut these, they're glass, and I think it's in 2-inch increments you can get them ordered. So there's a lot of flexibility. It's obviously not an inexpensive system, but the accuracy is really, really high and the build quality is unbelievable. So I figured for this lathe, I would just go ahead and bite the bullet and get a really nice system to go along with it.
I had a problem to put a DRO on my Craftsman. All the surfaces are round,
Yeah.
All these other lathes, they got all these nice square, flat surfaces. Everything on my Craftsman round, Terrible.
I had a hard time getting that.
That's the trouble with the old machines. They don't have any style, or they've got all that.
Lots of style.
They got sexy hips, but you can't mount anything to them. All the new stuff is real boxy, and it's real easy to put in.
Yeah,
Bridgeport, I had issues with the Z scale. I had to make some standoffs and affix those to that so that I could mount it. I couldn't put the scale right up against it.
On my old Dual, I had to put. I actually drilled pilot holes, and I went in with a spot facer and used the pilot hole to pilot the spot facer, and I spot faced 4 places to put little pedestals to mount the scales. That's the only way I could get it on, because it was casting, and it kept. None of them were the same.
That's essentially what I did.
Yeah.
Relative to digital readouts in general, I know as a hobbyist this would be totally out of the question, but since I still make a living doing this, the reason I bought the Heidenhain PT 855 digital readout way back was the fact that it had, before anyone else had this, it has the position indicator where there's a little box that drives along, and when you get anywhere near close to the actual reading that you've punched in as a delta measurement, that box moves along and comes up, and you can visually see it. So it's like using a Travidile instead of looking at numbers. There's just no replacing that analog connection of seeing when you're there, and the resolution of that position indicator is exact, meaning if you're right on pixel for pixel where that indicator is centered, it's right on. It's not an approximation. And that lets you use the other things that it can do is you can write programs where you say, okay, you're going to go to this diameter, Z. As soon as it gets there, the program moves. As soon as you hit the box, the program moves to the next step, which could be whatever. So you can write lathe programs, tool changes, all these things. That indicator is crazy efficient. And I think there are Haydn or be it Bosch and Lohm or versions that have that now because Heidenhain bought them and they brought some of that over. So it may be, just to give you an example, my first PT 855 is over 25 years old. When I bought that, it was $2,800 just for the box back then.
Wow.
Worth every stinking penny, trust me. But I understand hobby use, that's tough to justify. But I just got another one off of eBay for I think $1,100, the used one, and because I actually moved it back and forth between my lathe and my Bridgeport, because you can program it for each of them. So now I'm not moving it back and forth anymore after 20 years. I actually have one on each one. But that position indicator, if you ever look again for a digital, especially on the lathe, and having tool offsets, that has 99 tool offsets, and you've probably seen my wall of Aloris holders on the rack, and that and the solid tool post where all of those holders repeat is just miraculous on a lathe. Like Stefan Gottsbender, he duplicated all that stuff, and he's doing that for a living. It just turns your lathe work into something that is just a joy. because you know where you are. I can go grab a CBN hard turning tool, drop it on the tool post, cut a diameter, and be within 2/10 without even doing any fudging. Just right off the bat. If I need to, I'll stay 5 thousandths away or whatever. Take a test cut, see where it is, take the difference, and that's where I say that high resolution comes in. But I realize it doesn't apply, unless you can justify it. But if you ever can, man, it's amazing.
So, Robin, interestingly, again, that buyout of Accurite, Heidenhain has put that feature in the newest versions of.
That's right. I thought there were ones that were there, and you probably witnessed that. That is just it's like a game changer relative to looking at numbers, trying to.
Exactly.
It's just ridiculous.
If you are looking at numbers, another neat feature about this, and this is kind of why I ended up going with this guy rather than the comparable Newell, is when you're traveling quickly, it'll bump up the size of the numbers. So while you're traveling, the axis you're moving in will get bigger on the screen, and the screen's pretty big to begin with, which is nice. But yeah, and then you can set it to the have the traveling graph essentially.
Yeah.
Tell you where you need to be.
On machine things where that matters, like you're going in, you're doing a snap ring groove or something, and there's a feed rate that keeps the thing happy, and it's not going to chatter or drag or whatever. And you got to go in and go bang, get to the bottom of that thing, pause for a couple revolutions, and get out. That's when you need those things where that visual indicator is there. You're not counting numbers because your mind just can't process the numbers fast enough for that. So it's very, very, very worthwhile if you can. Now I knew Accurate. I was pretty sure that they had models with that on there.
Robin, does it show both at the same time, or is it one or the other?
Oh no, same time,
Oh,
all
okay.
axes at once.
I do little tricks like switch over to a different SDM page and set it so that I'm always driving towards 0. So I don't have to think about the numbers that when I hit 0, I'm at my mark.
Mm-hmm.
So little trick for those hobbyists that want something similar to that, but don't want to have to think about the numbers they're trying to hit.
Us hobbyists need every little bit of help we can get. If it's built into the hardware, wonderful. That's for a fact.
Well, Aaron, what model do you have there?
This is I'll make sure I've got the right number. I think it's a 200.
The 200,
Yeah. 203. Sorry.
203.
The previous version was a 200, and now they've changed it to the 203, 303, and I can't remember what the one with. I think you can get 4 axes. I can't remember exactly, but this one will do 3. That's why I got it. So if I want to, and I do at some point want to put a scale on the compound, it'll split this out, and I can have three readings at once.
Well, before the discussion started, I was telling Harold and Phil, I want to make a little gizmo that I'll hook up my Z and eventually my Quill DRO scales to, and combine them and do some cool stuff like sum them together and send them into one of my inputs on the DRO box, and then have the other one not be affected, so that I can, I bring the knee up 2 inches or drop the quill down 2 inches. It's going to sum those together correctly so that it shows the correct reading on either my Z or the K axis.
So they're no longer relative.
Yeah, and I can flip the switch and flip the switch, reverse them, or flip the switch and leave them independent. So I'll have 3 ways I can do it.
Yeah, there's 2 features on a DRO that are handy. One is summing, and the other is vectoring.
Right.
And they're both handy.
Right. I don't think mine does summing, but that's not that hard to do with a microcontroller these days.
Yeah, you guys are building all your own. Like I say, these things are a toaster. They better work when they get it come out of the box.
Yeah,
I'm with you, Stan. I'm not cutting wires.
Yeah,
I'm not cutting into a brand new DRO.
I'm not cutting into the DRO either. I'm just making an add-on box that you plug in you plug it in, and you plug it into the back of the DRO, and you got a switch you can flip to 3 different modes.
No.
Well, I like playing with Arduinos and stuff, and I've got some extra scales in a drawer. They're from two different manufacturers, so where the signal's at changes from one pin. You know, they're on not on the same pins. Sort of drives me nuts. And I don't have an oscilloscope. If anybody wants to contribute one, I'll take it.
You want an oscilloscope? You pay for
Yeah.
shipping, I'll send you one.
Yeah, well, I've got plenty of them available. That just the shipping would kill you.
Are they that big?
Got all different sizes available. They've been throwing them away.
Yeah, they're all going digital now.
Yeah.
Oh yeah.
For $300, you can get a very capable digital scope that would be more than sufficient for a Rigol or whatever. There's plenty of them that are in the 300, 350 range that are basically ultra high performance and easier to use than any relic that you'd be using.
For
You
sure.
do realize you're talking to a redneck.
One thing to mention to Phil, relative to the scales, when you have two square waves that are shifted 180 degrees, basically they're 90 degrees shifted actually. You can use all four edges of the scale in accounting mode to get 4 times finer resolution than just the single channel. So, and on a lot of quadrature counters, like on the PLC I was talking about, you can actually pick whether you want. I think we lost him.
Yeah.
I used to do PLC programming with wonderful things like ladder
We
logic.
lost Randy.
Of course, once we got the Triconics, they had the little symbols, logic symbols, which worked a lot better.
Sorry, did someone ask me a question just then? I dropped off.
No, I don't think so.
Oh, okay, that's fine. I'm sure I heard my name, but that's fine.
The other thing when you were mentioning about higher resolution, they typically don't do it by trying to make the scale finer and finer. I mean, they do that in other ways, but instead of only having a Schmidt trigger that captures basically a certain point on the wave on both sides, they actually look at the sine wave, and they have circuitry that electronically divides that and says, okay, we want within that sine wave, we want 37 steps or more or whatever. And so it actually picks those out. And that's how the Heidenhain actually does the subdivision from the raw scale divisions.
Yeah. I mean, to be honest, that might be quite an interesting project to modify one of the cheap ones, because the sensors are there, and what it's doing is you've got the comparator built into the unit, which is doing that logic step, the switch.
Yeah.
If you were to remove that and just send the analog signals straight out, you could do just that. You could monitor channels 1 and 2 for channels A and channel B, and you could read the analog value as it's varying, and like you say, you could interpolate the difference, and that would make for quite an interesting project.
The thing that you have to watch out for and is that you can do that, but when you even on Heidenhain, they will talk to you about different qualities of scale, and as you get to higher and higher resolution scales, the preciseness of the read heads and the positioning and all those things has to be good, because just because you can subdivide the sine wave doesn't mean the sine wave is accurately representing the motion. So the higher and higher precision scales, they'll say what the maximum subdivision level is that's going to have any relevant accuracy. So it might be that even though you could do that technically, in between it could be garbage as far as your, it would still count and do everything correctly, but it wouldn't be nearly as accurate as you think in between the main counts.
I mean, the other issue you have would be the etching of the image on the actual glass scale as well.
Yeah.
You'd have to make sure that each division was accurately etched on, because if one was just a fraction further along, then the reading would be completely out. So yeah, absolutely.
Hey, Harold, add Randy back in.
Oh, did he go away?
Yeah,
Sorry.
there he is.
I'm trying to
brought
watch
me
the
off,
comments. I'm trying to watch the comments and listen to you guys. And it's like one-legged man in a square dance here.
He's blacklisted already.
Our time's up anyway.
Yeah.
So thank you folks for coming here to participate today. And thank you guys that are out there watching and making comments. And hopefully you'll come back next Sunday. Thanks, everybody.
All right. Thank